So first, let's create the problem. And then after we have the problem, we're going to show you how to fix the problem. Usually that's how we go, right? So let's say I have, again, a sample class that I usually do, the container class. So I have a container class. Obviously, I'm going to need all those beautiful stuff over there. Let me just take them over here. And I need my utils. Let me bring that one too. So I actually, yeah. So I have a class called container with a constructor and a display, and I have an operator plus that adds 2 containers and return a container back. Any problem with that? Look at the code. Simple, straightforward, nothing extraordinary happening. I have a container. It has data in it. Data is by default 0. I have a operator plus that receives a container reference at right side, adds the 2 containers and returns the left one out. Essentially, this creates a binary operator, because I see some of you are looking with kind of, huh? Okay, so binary operator plus with no side effect. Which I did not enforce, and I'm a bad person, so I put a const over here just to make sure we understand what we are doing. Okay? And the reason I did this, it creates a temporary nameless and returns it, so no harm done, and life is beautiful. And since I like things to get printed using cout, I'm going to put this thing over here, and that's printing the container with cout. Are we good? You okay with this? Everybody's fine with this? So we don't need this. Let me close it. Okay, that was container. Now, what I'm about to create is this. So I'm going to actually say over here something like int main and return 0. So say I want to create a function that adds 2 integers. Stupid example, but the easier to understand. So let's say I have 2 integers over here, say integer a and integer b, and c, and say a is 10, b is 20, and I have the c, and I want to, for some, I don't know what reason, I don't want to write c is equal to a plus b. I want to write c is sum of a and b. Okay? Problem with that? To do that, I write the function like this, right? So the function on the right is int sum, right? Then I'm going to write int a, int b, and in here I'm going to say return a plus b, obviously. Are we good with that? Now, by things that, from what we know in doubles, if I have, say, a couple of doubles over here, and I set the doubles to certain values, if I want the same thing to be done for doubles, I have to write over here double sum and double a and double b, right? I'm just overloading the function, and I'm going to write return a plus b. So the logic inside the two are different. They are same. So they're both, that's plus, and this one is plus 2. One is overloaded for double, and the other one is overloaded for integers. So in here now I can say something like, what do? I say cout C and L, and that's the 2 integers. And then I'm going to say Z is set to sum divided by, sum, and it receives A, X, and Y. And in here, I'm going to go see out Z. Z. These are like, this is like the very first thing that actually we learned when we came to class, right? Good. So now, like that container, I can have another class that is almost the same. So let's add another class over here, and I'm going to call that Mark. Okay. So what is Mark? Mark holds some data to it's going to be somebody's mark, and it has some value in it, and adds up the two values and returns the mark, and it says MK is that one, right? And I do the same thing over here. And I'm going to put it for mark. So mark and container are almost the same thing. It's just a different type of purpose for it. One is just a container, and the other one is a mark. Are we okay with this mark class of mine? Okay. So because the mark over here has a plus operator and the container has a plus operator, I can apply the exact same function over here as I did for sum for the container, right? So I can actually say container sum and then container A and container B, and in here I can say return A plus B, right? Are we okay with this? And I can do the exact same thing for the mark. I can go mark, sum, mark A, and mark B. And in here, I can say return A plus B. Boring, right? I keep doing the same function. I'm just changing types over there. So the next thing I'm going to do over here is to actually use those stuff over there. So that mark thingy that I have, so let's have the mark and a container created. So these are the mark and a container variables, or whatever we call it. And then we can actually show the mark. And so the mark is N, and oh, container is C2. Darn it. Do I have anything else that I can put over? That's A and B too. Darn it. Let's make this I and J. I, J. Okay, I'm one of those people who can't copy properly. So K over here is I and J, and I'm going to print the K. Okay. Now I have M and O and CB. Beautiful, so good. So that's that. And we can do the exact same thing for the container and for the mark. Right? So I have Y and Z, X and Y, I and J, M and N, and C and D, and sum for I and J, sum for X and Y, M and N, and C and D. And because these sums are all overloaded over here, obviously when this beautiful program of mine runs 3 years later, what happens is that as soon as it runs and comes through, all these things are getting creative boring. But when sum with I and J is happening, it goes to the one with the integer. It picks the right type, correct? And then it comes over here, and now it goes for X and Y. It picks the one that is double, obviously, right? And then when it comes to the other one with M and N, obviously it's going to go to the one that is marked because M and N is a mark. And it's the same thing with, and it's the same thing with the container. So it goes to A plus B of container and prints it. And when we look at it, everything works as they are supposed to be. Are we okay with this? Are we okay 1? Are we okay 2? All right. So when you look at the functions that we have written over here, could someone please be kind enough and tell me, from an outsider's point of view, what is similar between these functions? The name and what do you mean by definition? Logic. Logic. So the logic is the same. The name is the same. What else? The way they receive arguments and return values. The signatures are not the same, but they're very, very, very similar. So imagine that I have like my 9-year-old that doesn't know C. Okay? I ask her, hey, I'm tired to write these things. I'm going to give you a blueprint. Get this blueprint, and whenever you see a type coming up, write this, copy this thing for me. And she says, what am I supposed to write? I'm going to say, this, whenever I write a type, you replace it with the type that you want. Sum is sum, and another type over here, A, and another type over here, B. And you just return A plus B. So essentially, if I did not have these, I'm going to say, just take a look. If you see in here, it's an int and an int and an int, copy this, right? Paste this, and replace the types with int. Right? Correct? And then when it comes over here, I'm going to say, look at this one. What is this? It is double. So double and a double and a double. All you need to do, again, copy this, paste it, and change this with double. Double. And double, double is written, correct? Okay. So if in here, my question is that if my daughter is doing this and I do not have these two lines, will my daughter implement anything for container or mark? No, because it's not used. I told her, go through my code and take a look at it. Whenever you see the sum is used, see what types are passed to it, create it for me, right? Now, my daughter's name is compiler. I can actually do that. So what I do, I actually write that, and all I need to do over here is to write template, if I can write it, template, and then write over here type name, type. And I do not need to write anything anymore. Which means now, not at compile time, not at runtime, but at compile time. Compiler, so if I don't write anything, no function will be written. The template's over there, but no function will get created in the executable. I'm not going to have nothing translated if I do not. Actually, I should have done something here. Give me a second. I want my thingies back. Give me a second. Do I have them back? Yes, I have them back. So what I'm saying is that if I do not have any of these, if these are all commented and do not have any of these, the template is over there. Well, when the compiler looks at it, it says, I don't see no sum, so I'm not going to create anything. Therefore, executable will not contain a function called sum. But as soon as you uncomment this one, now when compiler compiles, it says, oh, let me see. Let me see. There is a sum. The sum that I have over there, and it kind of matches what I have over here. And there is no function created for sum. I looked everywhere. There is no sum function. Somebody showed me a template to create a sum. So what they will do, the compiler will simply take that template, replaces the types with the types of the thing, and then I'm going to have integer sum, yada, yada. That's called templates. So whenever you're applying the same logic for different types, you don't have to function and over and over. The compiler will do it for you, and it will separate the things that's there. This is the ultimate polymorphism, which means the functions are created based on your need. You don't even have a function, because when you have virtuality and stuff, you have the function. But the function may not be called because the pointer of the child is not the child is not pointed by a parent. Because of that, the virtuality doesn't come to play. These things happen. So that virtuality, although it's a true type of polymorphism, but you still have your code. When you create a function, your function will get compiled, and the executable, that it will be translated into binary and will be embedded in your executable. With a template, it will be in your executable if it is needed, and it will not do anything other than that. So it's a beautiful thing. So now if I actually take it off like that, you will see that that template of mine will work for everything. And when I run the program, it literally works identical to overloading all those things. Now, obviously, there are many scenarios that you want to write a sum, but the sum is not exactly matched to what you want. Like, for example, if I want my container sum be different than the normal sum that I want to for anything else, feel free to have container sum, container A and container B created and return A plus B. And we're going to say, see how this one is different. Ah! Okay?
So for the temp, does the type need to be the same?
No. What do you mean? The type of read the things?
Like the
No. You can have it different. We'll to it. Baby steps. Okay. So when you have something, remember, templates compiler always wants. It's like any automatic thing, like any self-driving car or anything. It does it by itself until you take over. Your action is always prioritized on what is automated. It's the same thing over here. If you overload the sum for the container, it's not going to create it for you. That template's going to be completely ignored, and your template will take over. So if you don't like one of those things, by all means, write your own version of it, and that template only applies for others. But still, lots of time saving happening over here. And now if I run the program now, you will see that it works the exact same way, but the difference is that the container is going to be different. So the other ones are running with the template, but the container is not. So your overload always come first. Always. There is no discussion about that. Now, my friend over here is asking, can the template have so many different types? Can I return type 1, type 2, and type 3? The answer is yes, you can. But for now, stick to 1. The reason I tell you that is that you always, there is a general rule of programming that is, you need to be able to guess what the function's going to end up when it's written by the compiler. If you are confused by it, compiler will be too. You follow what I'm saying? So essentially, if I have over here type, I can have many types over here. I can keep going. Type 1, type 2, I can keep going. Okay? But that makes it very confusing. Try when you are, usually when you are having a logic applied in your functions, that logic applies to the main focus of your function, not 5 different things. If you are having 5 different things, it means you are designing something incorrectly. Okay? So I'll explain. So down to this point, we know how the function templates are created, right? So function templates are you simply write the best way to write a template is to first write it for your type, okay? And then after you write it for your type, add a template at the top and change the types that you created to a general name. That type doesn't have to be type. It could be does not make any difference. So people always say, should I write type over there? No. Anything you put over there will work perfect. No difference. It's a placeholder. I'm saying my type name is so Sam and A and B. It works perfectly. No difference. Everything's fantastic, right? As long as you name. So essentially in here you are saying my placeholder is this. So many programmers, because they don't want to type, they just do T. For some reason my insert is on, I think. There you go, yeah. Many programmers do that. That'll do too, okay? Or type or whatever you want, okay? Now, if you look at the older versions of C++, you will see that this happens too. Potatoes. It's the same thing. They change it to type name because it just makes more sense. Okay, see, it's the exact same thing. So if you see in front of the template, they say class T, that class is actually type name. Okay, don't think, oh my God, a class, that's a different. No, it's not different. Class is type is class, potatoes. So I'm going to do it like this, and I'm going to say, and I'm going to bring it back. So this is the old one. Oh. The old way. All right? So that's function templates. And please beware, if you want to pass references to this template, just make this a reference. Exactly like you type. It doesn't matter. Or if you want to make sure that is that one, you can actually say over here, type name. Yeah. So just put anything you want to do, that is your type. You can do the exact same thing as if it's your type. If it's a pointer, you can write T pointer. If it's a reference, you got T reference. If you want it to be constant, you can write constant T reference, constant T pointer, anything you want. Okay? So yeah, as I was saying, you can do it, of course, you can do it like this. See, constant type reference. So if if I do not want things to get copied, I'll write it that way so it actually, now, better? Okay, so if I want the reference to be passed, I can do it like this. And I'm going to come to the next point right after this. Yes? So it returns an int. You can say int sum type A double B if you want to, as long as the type is involved in the signature somehow. Signature, not the return type. Yes. If it's a match, yeah. If it's a match, yeah. You cannot have, again, like if you are confused, compiler is going to get confused too. Like if you are writing a sum that returns a double. So you're writing a sum that returns a double, receives an integer and a float. Then you're going to say, these are three different types. How the compiler is going to act. I know it's going to act, it will, but what is it going to do? I don't know. If you don't know, it means compiler don't know. It means you've written a bad code. Okay? Don't do that. Now, the next thing I want to tell you is that every single template must come with explicitly exquisite comment and documentation. Why? Because it's a type and it can be generalized to many different things, you have to tell to people who are using your sum what hidden features will be applied in this. For example, tell me, for my sum to work, type A and type B, what specifications they need to have for this thing to work. Easy way to say, plus operator should be overloaded. Okay, so number one. So type A and type B must support plus operator. So you write a summary. You put the slash 3 times and poof, it expands like this. You explain everything in here. So when somebody hovers the mouse over it, they can see what your template is supposed to do. So this one, so number one, T must support T operator plus const T reference. Okay? It must support this. What else? This is your, by the way, that's the question for your final assessment. You are writing a template and you are mentioning what features it needs to support. Now think, please. When this function is called, what is going to be invoked behind the scene without you knowing? It's structure. So the structure is that's for everything. Anything that comes to being, just like everybody dies. That's not a hidden thing, man. I wish it was, but.
We receive a copy, so structure.
Hence, what does it need to have? Copy. Do you see assignment? Copy constructor. Because objects are passed by value, T must support, so T must support copy construction. Okay? It must support copy construction. And it returns the same thing, so it's for both. Copy assignment, we don't care. You're going to say, not have memory leak, we don't care. As long as it supports its own copy construction, my sum works with it. So T over here, type parameter, or maybe I should have written it over here. So in here, I'm going to say returns the sum of A and B. B must support operator plus and copy construction. A. What do I write with A? Parameter left parameter. It doesn't have anything. Parameter. I don't know what to write for that, so it's right parameter. So yeah, I don't know. Yeah, right. I'm telling you, sometimes commenting takes twice as much as you actually code. Okay, so it's gonna be a copy of sum of A and B. Okay? So when you do that, then when you actually come over sum, it actually shows you all the things about the sum. Returns that one, left parameter, and so on and so forth. Okay, so it actually shows all the things that it's supposed to do. No, they don't have resources out of this class. You don't know if they do.
In case they do.
You are saying it has to, when you are saying it must support copy construction, the person who's writing the code must be wise enough to know anything that needs copying must be able to destroy its resources if needed. You don't need to mention that. Don't put extra stuff. If I would write this thing and think that OOP244 students are going to be using it only, I would do that. But when you're in a professional environment, everybody knows when something's being copied, it needs to handle its destruction. Nah, not at all. Okay, so that's that. But this one, how about this one? What does this one need? It's a trick question. Pardon me? No, it's not copy, it's reference, because it's reference, nothing's going to get copied in the arguments. Just plus operator? What for? What does it need copy constructor for? For returning, thank you. Oh, yes. So it still needs copy construction, but for returning by value, not receiving the arguments. So still it's the exact same thing. This is much more efficient than the other one because you have two less copying happening. It's only one copying that is happening, right? So it's much more efficient than the other one, but still it needs copying, so it's the same. That's why I said it's a trick question. All right. So this one is with reference, a func template with reference.
So in the version, is not constant reference. The copy constructor will get executed when passing the parameter.
One more time. Let me.
The first version.
Previous version.
Yeah, the previous without constant and the reference. So in this version, will there be any constructor executed when passing the parameter or just?
Yes, of course. So you have one copy constructor, two copy constructors, three copy constructors, at least. Now, what happens in A plus B, you don't know, and we don't care. But this function needs three copy constructions of the same type. Of course, if this type was type 2, then there's a different story. Then you have to mention that one too, but we don't care. But because this one is returning, receiving cons, no copy construction here, no copy construction here. Only one copy is returned over here. All right? All right. So let me see what do I have over here that is. All right. So now from what you had in if I want to, let me just take this off in here and take these things off. Remind you from IPC 144, if I want to sort an array of integers, remember bubble sort? Yeah. So we did something like this. We had void and we had sort integer, integer pointer, some array, right? And then we had integer size. Then in here we said we have an I and j for the indexes, and we're going to have 4 I set to 0, I less than size minus 1, I plus plus. This is standard. Okay, so and then we have a 4, again j set to 0, and j being less than size minus I minus 1, and j plus plus. Oh, okay. And then depending on if I want to do ascending or descending, I'm going to say if array j over here is less than array, say, j plus 1, then what I'm going to do, I'm going to swap the two. So I'm going to say swap. Swap, what do I swap him? I'm swapping the array j and array j plus 1, right? And how do I write the swap? That's a 2-second thing. So void swap. In here I have integer pointer a, integer pointer b, and in here I have int temp is set to target of a, and target of a is set to target of b, and target of b is set to t, and they're swapped, right? Are we okay with this? So that sorts an array of integers for me. So essentially, if I have something like this, an array of 13 integers, I can say sort a, and size is 13, right? Then I print them out, and so I'm going to say over here prn array void prn array. And how do I print the array? How do I print the array? Integer pointer a, integer size. So in here I'm going to say for integer I set to 0, I less than, what am I writing here? I less than size, and I plus plus. In here I'm going to say C out AI, and if I is not equal to size minus 1, then what am I going to do? I'm going to do C out comma, right? Are we good? Does that make sense? So it keeps printing and it reaches to the last one. It's not going to put the, if it is, yeah, I think we're good. So now I can say prn array a and 13. So that array that I have, hopefully if everything is good, 3 years later after it compiles, it's going to be sorted in a descending order. Are we okay with this? Are we good? All right. So if that's the case, if this is what I do, how can I generalize this sort thingy to be able to sort anything? Not only integers. I want to be able to sort names. I want to be able to sort whatever I want. How do I do that? First of all, and I want you to be all ears now. Who writes the code for a template eventually? Not initially. Initially, it's you. But who writes the code eventually? The compiler, correct? So the compiler needs the template of the source code to be able to write it. Do we understand this? Okay. Did I show you the compilation diagram at the beginning of the semester with the things? Remember that? When you are compiling each module, the compiler gets compiled separately, right? And when you create a header file, what does that header file do? That header file introduces a function or a class to the compiler and says, compile this. You don't need the source code yet. Just compile it. When you link it, the source code is going to be somewhere else, right? Templates can't do that. Because compiler needs the entire source code to be able to write it, you cannot have your template in a CPP file and only put the prototype. If you only put the prototype, what the compiler sees is a template with a prototype. There is no body. It cannot generate the code for you. Because of this fact, compilers need the entire template to exist in a header file, not in a CPP file. So a template module only has one header file. It doesn't have a header file in a CPP. Do we understand this? You cannot put the source code of your function inside the CPP file. It has to be in the header file. Are we okay? Are we okay? So, very first thing I need to do, I need to take, well, that print array thingy, let me fix that first. So print array is 3 seconds, okay? So if I want to template that one, what do? I'm going to, because this has to do with printing arrays, not sorting. I'm not going to put it in this. So I'm going to create over here a sort header file. Was it here that I compiled and something didn't work? By the way, so let me just explain to you. Once I created the file over here and I put the extension CPP, but I wanted the header file. Then I say, oops, I made a mistake. I came over here, clicked on it, yeah, and then changed the CPP to a header file and moved it up here. Can't do that, remember. That was a mistake. I didn't know that compiler does that. If you do that, compiler still compiles your .h and it gets screwed up. If the extension is wrong, you have to delete it and create a new one. Just because that happened to me and I was like half an hour trying to find out what the heck went wrong. Don't do that. So add a new item. So right over here, I have to say sort.h, okay? So that's going to be where sort.h is going to be. And obviously in here, I'm going to say, if not defined, stds sort h, and in here, I'm going to say define, and that's that. So that's my empty header file, but the heck with it. I don't want that now. Let's go back here first in here and do this print thingy. So whenever you want to do convert a template to a function to a template, very first thing you do is this: template, type name. Let's call it type so it looks better. Okay, you can make it capitalized if it makes you happy, but let's make it something so we know it's a type. Then you have to go back and take a look at your code. What needs to be templated in here? Like, do I need to make that integer size type size? No. Number of things are number of things. They don't need to be templated. 5 cars is 5 coffees, is 5 chairs, is 5 lights. 5 is 5. It has nothing to do with the template, right? That's what you need to look at. So, do I need to make that integer pointer a template? Of course. That is the array I'm sorting, or printing in this case. Printing, right? So now in here, I'm going to say type. Then I'm going to go over here. This is an index of a loop. I don't need to change it. Nothing is needed. Actually, I'm done. But you have to now document it. Now tell me, what things need to be here so this thing can actually print elements of any type of array. As soon as you want to look at that, take a look at take a look at the name of the variable that you have and see where it is involved in your code. That's the place you have to look at. So the only place I have A is at line 26, right? So AI is essentially an object of type, correct? And it is being printed on cout, correct? So the only involvement that I see over here is that the object of type A of type should be insertable into cout. Done. So if it's a series of names I'm printing, I can, no problem, as long as the name is printable on cout. Anything that is printable. So if I run this program, why is it giving me an error in here? Available template is missing. Argument list or variable template. Huh? Did I miss anything in here? Let me see if it's... No, it's IntelliSense being a little too behind. Anyways, so as you see, it works the exact same way. No difference. Are we good? We okay? All right. So we could actually add, and like in here, we could do something like this, right? Ascending and descending, see what the sort is going to do, but we're not going to do that. If and many people are not comfortable with descending sorting, so I'm going to make it ascending, so you see it goes from small to big, so we are all happy. Okay? All right. But you can simply have a Boolean over here, and depending on the value of the Boolean, have the proper condition, so it's going to sort any way you want. Are we good down to this point? Now the next thing I'm going to do, I'm going to take everything that is involved with sorting. I'm going to just exit, cut it, and put it in my sort.h. Okay? Then I'm going to come back over here because I don't know about you, but I always forget. So in here I have to say include sort.h. Are we okay down to this point? Now we come back to sort. We put our thinking hats on. We start from the first function, and each template command statement only applies to the next scope. That's it. Okay? So if I want to actually start doing template in here, I'm going to say template, type, name, type. Okay? So obviously, I want to change these two types, so they both need to be type. So this is going to be, why am I looking there? This is here. Okay, type and type, right? That's done. Now, this integer, does it need to change to type, or it just has to be as is? Type, because that's my temporary thing. Type. And immediately, right over here, I take a look at it. I see a copy construction is happening over here. Correct? That's copy construction. Assignment at the moment of creation is a call to a one-argument constructor. And it's that one. So copy construction is one. Assignment, copy assignment is another. That's it. So in here, immediately, I have to say name type. And here, I'm going to say copy and copy rule of three. Okay, because that takes too long. And the rest you can just write over here, whatever. Huh? Rule of we know that the rule of three covers everything, but yeah, that's rule of three. That's a destructor for the t, right? So this one, he's actually right. We need the destructor for t if needed. But you never mention destructor for some reason, because everybody knows that objects die. So they need to take care of it, okay? So in here, I'm going to say swaps the two arguments. Argument content. Whatever the swapping is. So are we good down to this point? Yes. Then you don't do anything. If you don't need rule of 3, you don't even need copying. If the object as being swapped has all the information within, it doesn't have any resources outside of its scope, it doesn't need anything. Right? It doesn't need anything. All right. So that's that. Now sort. Again, template, type name, sort. Oh, type. Anyway, so type. So size, we don't care. We know that from the thing. But this one, we know it has to get changed to type. So that's type. We come over here. Integer ij. I don't care, nothing. In here, we're going to come. And that's that one. Oh, there you go. So greater than operator between the two types are needed. Greater than operator between the two types are needed. And because swap is used in here, you have to add all the swaps rules in this one too. Okay? So you have to say rule of 3. Yes, yes, yes. Or you can say, but it uses the swap template. Somehow, anyways, it's like a legal document. You have to write something so if something hits the fan, they're not going to come to you. They're going to say, I documented it, go take a look. Okay? Okay, so that's the thing. So yeah, so in here, it's got to be rule of 3. I think rule of 3 is fine. Rule of 3. And what is the other one? Operator greater. And the summary over here sorts the array. And this is the array. The number of elements of the array to be sorted. Okay? Are we okay? So now we save it, and we have our template. Let's go back over here and see if it actually works. Okay? Run forest run. And there you go. But it already worked for integer. Okay, let's try it with other stuff. What? Print array? Okay. When somebody says sort array, does printing come to your mind? Okay. So that's called hidden logic. Like if you put a sort header file and sort header file prints the arrays too, then everybody's going to go, what? I thought it just sorts the thing, you know? So don't put extra stuff. But thank you for the question. So now, let's say I have a class called name. Ta-da! Okay? The class name of mine, it has copy constructor, it has copy assignment, it has destructor, it has plus operator, so it can work with our sum, but we don't care. It has less than operator, which we do not want. We want greater than operator. So I'll fix it. I'm going to go greater, and I'm going to do greater so that's greater than operator. Or I can have them both. Okay, so that's that. And it is displayable. So for PRN, it works because it actually gets printed on the So, and now I can actually have my main expanded to something like this. I have an integer, double array. I have series of names, and I call the sort for all 3 of them. And when I run the program 3 years later, what I will see is this. What I see is not that. What I see is this. Sorry, I'm not going to show it because it's embarrassing. Let me just do this over here. OStream reference print array. OStream reference OSTR is equal to std cout. OSTR. That's better, right? Yes. Return OSTR, and now I can do this. I'm not going to show the output because it was bad. I needed to go to new line. Right? Now, run it one more time. And now I have this. Ta-da! Okay? It's a beautiful thing. Templates are amazing. Seriously, just imagine you had to write 3 different sorts, one by one. Like this, you just write it once. If you have a good design, then you just write one function. And if some of the functions don't work for this, then overload them. No problem. Okay? We have specializing too. It's called specializing templates. So you can actually tell the compiler, see, the good thing about a template is not only that it creates the function for you, but it's the fact that if it's not used, no code will get generated. So if I overload the ones that are not covered, I am adding the code even if it's not used, correct? Specializing says if it's not the way, if this logic is not good, use this logic instead for those types. We'll talk about it later, probably the next days that you're coming in, because I don't want too much information to get in. But you can easily specialize a template, function template, saying that generate like this, but if the type is that, then generate this one instead. No problem. You can do that. We'll get to it. So that's that one. From the faces and the looks and everything, I see you're tired, so let's have like 5-10 minutes break, and I'm going to talk about some 3-4-5 stuff. So, what was polymorphism? That's going to be in your final test. What is polymorphism? Seriously, you're at the interview and you want to get the job for your co-op or whatever. It says, what is polymorphism? You're going to say, it's the name thingy with a...
Working is different. Like it works in
Okay, guys, do it this way. Same action, done in different ways. 3 seconds. Not the name thingy that is the same thingy, but it's... No. Okay. So same action being done in different ways, that's polymorphism. Okay? Now, in C++, polymorphism is implemented in 2 major ways. Fake, real. Ad hoc is fake polymorphism, which means ad hoc, which means when you look closely, you say, oh, that's not polymorphism. It looks like it, but it's not. Real, universal, is real polymorphism. Okay? Really, it's an action that takes place in different ways. Okay? Now, let's actually get through it. Coercion, casting. If you think about it, if that's the case, C had polymorphism too. You wrote A is equal to B plus C. No matter what the types of those things are, you had an answer, right? Your plus operator works with integer and integer, double and double, double and integer, float and long, right? But what happens behind the scene is not that plus operator is a polymorphic thing. it temporarily casts the values to make them to have the same type and then gives you a result. Or if you had a function that accepted a float in C, you gave it an integer, it upcasts it to a float. So if it's 40, it becomes 40.0, then passes to their function and a function. So C always wants to make things work. So if you pass something to a function that receives an integer, you pass a double, it drops the thing, it gives you a warning that you may lose some data, it gives you all those things, but still it passes it. That's coercion. That's not polymorphism. It's not a different action, it's just types being changed temporarily so things can kind of work. The other one is overloading. When you do overloading a function, that's not polymorphism. Why? It is polymorphism, but not really. Why? Because when you are writing, for example, the thing that we talked about like 2 seconds ago, when we actually wrote this, when we wrote, did I wad them all up? Yes, I did. Let me see if I can find it somewhere else. Yeah, so when we had these, oh, I called it A, both of them. So when we had these functions, we wrote some, we wrote some, and we wrote some, and we wrote some. And because it's same action different ways, we call it polymorphism, right? But that's not how actually the compiler works. When you create a function called sum like this, compiler looks at the types and behind the scene calls it sum int. And then when this one is getting generated, it calls it sum double. And for this one, it calls it sum mark. Do those names look the same to you? No, they are different functions. So that's, again, ad hoc. That's fake polymorphism when we look at overloading. Overloading is not real polymorphism. But we have two types of polymorphism that falls in the category of universal real polymorphism. Inclusion. Inclusion is they're essentially virtuals that you write. When you create a virtual function, the signature, type, everything that the function has with respect to signature is identical to the next one. You don't change the parameters. Compiler automatically finds out which one to call based on the type that is being set to. So if the type is, in our cases that we have for the project, that we have, we do printing our items that we print, it based on the type of the print, it picks the proper one. You haven't been in milestone 4 yet, but in milestone 4 you'll see there's a perishable and non-perishable. You're going to add to the type, and depending on what the type is, the proper write will be chosen and executed. Essentially, it automatically chooses the latest version of the function. Therefore, your function calls are identical. They are not different. Compiler doesn't choose a different function to call it. Automatically picks up the right version based on the virtuality of the function. Therefore, that's really polymorphic. And at the end, parametric is like the mother of all polymorphisms. You don't even create the code. The compiler generates it for you based on your need. You create one logic. Literally, you say, this is my action. Now do it different ways. You literally say, this is the way it's supposed to be done. You choose the type. And therefore, it's universal polymorphism. And this is the overview of polymorphism that we wanted to. We don't want to talk about at the beginning of the semester because you have no idea what is a template or a virtual. But now we know all these things. So ad hoc, casting, overloading, universal, virtuals, and templates. Okay. Now templates are even better than what we see over what we have seen over here. So when you actually look at, if you want to, this is the sort thingy, right? So let me just write it over here. And first of all, let me fix these. So this is B, not A. And this is going to be C sort. So you know what? I'm not going to talk about that today. I wanted to teach you class templates, okay? I'm not going to do that. Next time you come in, we'll talk about it so you can actually see what class templates are. If I talk about it now, that we're going to go bananas, and I don't want that to happen. Baby steps, exactly. Exactly. Let me see if there's anything else I can fill it in with instead. I'm just going to talk about constraint casts. But before doing that, you need to, I'm going to actually use the example that we have in the class, in the notes. And then after that, next time, I'm going to actually write you a proper one, something that actually is useful. Okay? So if you want to talk, if we want to say have some kind of a safe array created for an integer to make sure we are not passing. Did we do a dynamic array in this class? We didn't do it? We'll do it then. The next day you're coming in, we're going to do it. But let's say I want to create a safe type of array for integers. So I'm going to call it over here class. Int array. Okay. Now, if I create an integer array, obviously what I need to have is some kind of a size that the array has. So it's going to be something like int a or data, m data, and in here we're going to have some kind of a size passed to this thing. So I'll put over here, say 20, something like that. Okay. And in here I'm going to say public. And I'm going to have int array created in here, defaulted. Okay, and I'm going to make this empty. And to be able to access these 20 integers, I'm going to overload the index operator. So I'm going to create an index integer reference. And in here, I'm going to call it operator like that. And in here, I'm going to say integer index. And then what I need to do over here is to make sure that the value that is returned is properly set with that 20 size that I have over there. So what I will do over here will be this. I will write something like return m data, and in here I'm going to say index mod 20. Okay, so that becomes safe 20 integers, because if first of all they can access every single element over there, there's no problem with it. But the good thing about it is that it can, if they exceed the size, they're going to remain in their own memory. It's not going to crash the program. But anyways, we did template for functions. We can do the exact same thing for classes. So instead of having something like this, I can actually create something like template, and in here type name, type, and you can actually pass values to it. So you can actually say over here integer size. Okay? So now you'll see what I mean in 2 seconds. So now in here, instead of 20, I can put size. And in here, instead of 20, I can put size. Okay? The problem is that this looks beautiful to me. So, and also, I want it to be any type, so I'm going to put over here type. And I want any type to be passed to it, so I'm return, so I'm going to put over here type. So if you look at it, that little integer class of mine, array of mine, I cannot call it an array actually, instead of an integer array. Okay? I can actually, if I know how to create this, yes? This one? Oh, int array, yes, but no, index cannot be type. Index is the index. First student, second student, third student. First computer, second computer, third computer. The index is integer. Doesn't matter what type of element you have. So you don't change that. But constructor, you're absolutely right. I have to take that thing away. All right? It's much more complicated than this, but I'm just trying to give you an example quickly. So the complicated one we're going to come to later. Okay? So now the problem is that when you think about it, functions have signatures. When you create a template for a function, compiler can look at a function call. From the arguments of the function call, it can find out what to create. An array doesn't have, a class doesn't have signature. If you want to instantiate an array, you write over here array A. And what do you, how does it know from a class what is the signature so that it can actually make the type integer or pass the size to something? It can't. Because of that, you have to add the signature to the class while you are creating it. So you have to say, I want an int array of type doubles with the size of 100. Now it knows how to create it. So now I can have an array with 100 doubles that is safe. If they exceed the size, it's not going to do anything. And I can create another array over here with integers that is 10. And obviously, it's going to be like, I don't know, V, something like that. Okay? But as you see, the arrays, it's kind of crazy when you look at it. It doesn't make, like, it's nuts, but it works. So these type of classes can get created. And with this, you can do magic in C++. You'll see. Long time ago, Apple had this slogan. Everybody knows what a slogan is, hopefully. Okay? Apple had this slogan. It says, you want this? There is an app for that. Remember? Like, you want that? There is an app for that. Oh, you want to go swimming? There's an app for that. Okay? Anything that you would say, there is an app for that. In C++, you won't do anything, there's a template for that. Anything. You want to sort? There's an algorithm for that. There's a template algorithm for that. You want to do a binary search in a tree? There's an app for that. There's a template for that. Anything that you want to do, there's a template for that. You want to cast a variable to something else safely? There is a template for that. What is that template? This is the template. So down to this point, we just casted stuff. We said, I want an integer, cast it to a double, and things like that. So this cast that you see over here, it's done like this. So you actually write, say, you write static cast, you write what it wants to be casted to, and then you write what needs to be casted. What is the difference? Like, why the heck I had that little thingy that I wrote over there, int 5.5, it casted it. Why am I going to go through this? They are trying to make C++ safer. The whole argument with C++ was that it's too dangerous of a language. You have so much power in it, you can destroy everything. You can cast whatever you want to, and you can have an employee cast it to an integer. What the heck is going on here? Like, that doesn't make sense. So we need to put some kind of constraint. So you tell me what your cast is supposed to do, so I can give you an error if what you are doing is not actually that thing. Something bad is happening behind the scene. So they said, when you want to have related types casted to each other, you use static cast. With a static cast, you can actually say static cast double minutes. Minutes is an integer. Because they are both primitive type and they are related type of types, you can actually cast them together. Okay? And if they are not related, if that double thingy over there is, I don't know, a cat, and you're trying to cast it, then it's going to tell you, hey, the compiler is going to tell you, hey, you are doing incorrect casting over here. Okay? Obviously, it gives you the power. If you want to do cuckoo casts, you can still do. But you have to tell the compiler, hey, shut up. I want to do something crazy. Let me do it. But you have to tell it that you are doing something crazy. And that's unrelated type. So when you have two unrelated types, and you want to cast one to another, you have a regular integer and you want to cast it to a pointer. An integer and pointer are two different beasts. They are both numbers, yeah, we understand, but you add one to an integer, one will be added. You add one to a integer pointer, 4 or 8 will be added depending on the system. So they behave completely differently. They are not related types. If you want to actually have a number and treat it as an address, you do reinterpret cast. So you're telling the compiler, shut up, I know what I'm doing, just cast it for me. That's the one. That's one of the most crazy ones. Say you are printing a class. We said when you are printing a class, you have to make the method constant so it doesn't change the object. Because you are printing the class, you are not supposed to change the class, right? What if you wanted to count how many times this class was printed? You can't, because your method is constant, it cannot change the object. How do we do that? Easy. You put a property inside the class that is supposed to be added every time you are printing, and you unconstant it using the constcast operator. So constcast operators remove constantness. So you can say everything's constant, but that variable is not. And you can remove the constantness from it. I tell you, and I get goosebumps. I love this. Like, it gives you so much power. So even if something is constant, you can actually remove the constantness, but you have to tell to the compiler, hey, shut up. I know it's constant, but I want to modify it. Okay? Last but not least, dynamic casts are let me pause it. I just want to put it in words. if you have a pointer of a child, if you have a pointer of a parent pointing to a child, there is no guarantee that there is a child in there because the pointer is pointer of a base. It could be a base pointing to a base. So compiler always prevents you of casting a base pointer to a child pointer. Child can be casted to a base, no problem, because every child has a base in it. But a base not necessarily has a, right? When you are 100% sure that this base pointer is pointing to a child, using dynamic cast, you can actually cast it to a child. So treat this thing as a child.
So pointer to base becomes pointer to child?
Yes. But that's, in reality, you shouldn't be able to do it. Yes, monkey, exactly. You can make a monkey become a human. Talking, teach.
If you know there's a
No, but if you're 100% sure that it is, you follow, you walk through your logic, and you know at this moment, this base pointer is pointing to a derived class. You're 100% sure. If it's not, you're going to get a compiler. Oh, sorry, not compiler, runtime error. But if not,
It's called dynamic because the class is a dynamic type?
yeah, because it's dynamically doing it for you. Yeah. And those are the casts. So from now on, when you're casting, cast like this. But when you know what you're casting, because when you're casting, you know what you're doing, right? So choose the proper cast for it, and then you're safe. If that cast behind the scene is not what you want, it's going to catch you. And all those things are templates created. And that's the best example for it. We're going to come up to it soon. Have a beautiful day. I'll see you soon. Let me just shut down the computer quickly before the next prof comes in. Please don't ask me questions now. If you have questions, outside.